Over a century ago, astronomers initiated their initial exploratory endeavors beyond the boundaries of our galactic neighborhood. The observations they made were nothing short of breathtaking. Initially, these astronomers misidentified the distant galaxies as nebulae, perceiving them as indistinct, tenuous smudges of light against the vast expanse of space. Gradually, they came to understand that these were not mere nebulae, but entire galaxies, vast, sprawling systems, comparable to our own Milky Way, teeming with stars, planets, and other celestial bodies. The universe was found to be far more expansive and intricate than had been previously conceived. It was a period of significant and transformative discoveries. First, astronomers such as Edwin Hubble observed that the galaxies were not static entities, but were in motion, and more importantly, were moving away from our own galaxy. The further a galaxy was from Earth, the faster it appeared to be receding. This discovery gave rise to one of the most profound concepts in modern science, the notion that the universe is undergoing an expansionary process. The expansion of the universe was not limited to the galaxies. Space itself was observed to be undergoing a process of stretching and growth, with everything within it being drawn along by this phenomenon. This led to the development of the theory that the universe originated from a single, unimaginably dense point, which was later known as the Big Bang theory. During this period of significant scientific advancement, Albert Einstein, one of the most prominent figures in 20th century physics, was developing his theory of general relativity. This theory had a profound impact on our understanding of gravity, space, and time. The theory predicted phenomena that appeared to defy the limits of conventional understanding, including the existence of black holes, gravitational waves, and even the intrinsic curvature of space. However, one of Einstein's predictions continues to challenge contemporary understanding, namely that the absolute beginning of the universe will remain unobservable. Einstein's line of reasoning was straightforward yet profound. He postulated that even if the universe had a beginning, no matter how sophisticated our telescopes became, we would never be able to observe it directly. He offered two compelling justifications for this assertion. The Big Bang was not a conventional explosion in which the fire and debris would be visible. In the earliest moments of the universe, there was no light whatsoever. This period, designated the Dark Ages, commenced shortly following the Big Bang. During this period, the universe was a hot, dense plasma in which photons, particles of light, were confined, unable to travel freely. It was not until hundreds of thousands of years later, when the universe had cooled sufficiently for atoms to form, that light was finally able to escape and travel through space. This light is what we observe today as the cosmic microwave background radiation, which is a faint afterglow of the Big Bang. However, this radiation does not provide insight into the precise moment of creation. It is akin to a snapshot of the universe taken long after the Big Bang. Secondly, Einstein postulated that the expansion of the universe would result in the beginning being situated at an increasingly distant point in time and space. Despite the advancement of observational technology, the light from the initial moments of the universe will perpetually remain beyond the reach of our instruments. In this sense, the universe's expansion establishes a cosmic horizon, beyond which we are unable to observe. The initial point is effectively obscured from view, akin to a ship vanishing over the horizon of a curved Earth. For an extended period, these concepts remained largely theoretical. It is important to note that the telescopes available to Einstein were of a much more rudimentary nature than those in use today. With the advent of modern technology, it is now possible to observe cosmic structures and galaxies as they existed billions of years ago. At the vanguard of this technological advancement is the James Webb Space Telescope, JWST, which has afforded us an unparalleled perspective on the early universe. Nevertheless, even with this remarkable instrument, Einstein's prediction appears to be borne out. Recently, the JWST has revealed something astonishing. Among the countless ancient galaxies it has observed, it has also detected something unexpected, an enormous, mysterious void in the early universe. This void, devoid of stars, galaxies, or any visible matter, has prompted significant debate among scientists. Could this be a remnant of the universe's earliest days? Or is it something else entirely, something that challenges our current understanding of cosmology? Let us proceed with a detailed examination of the subject matter. The existence of cosmic voids has been a topic of interest for some time. These are vast, empty regions of space where the number of galaxies is relatively sparse. They are analogous to cosmic deserts, encircled by galaxy clusters that collectively constitute the so-called cosmic web. However, these voids are a relatively recent phenomenon, emerging in the modern universe, which is millions or even billions of years old, following the Big Bang. However, locating one in the early universe presents a distinct challenge. In accordance with the prevailing models of cosmology, the early universe should have exhibited greater homogeneity, comprising a uniform soup of matter and energy. The discovery of a void in such a young universe appears to be a highly improbable occurrence, at least according to the prevailing standard model. Some scientists posit that this void may be a remnant of the Dark Ages, a period preceding the formation of stars and galaxies. If this hypothesis is correct, it may provide insight into a previously unobserved era of the universe. Some researchers propose that this void could indicate a limitation in our current understanding of the early universe. Could it be that the universe did not evolve in the manner previously assumed? Could there be unidentified forces or phenomena that shape the cosmos in ways not yet fully understood? Additionally, there are more speculative, and some might even consider them to be somewhat unconventional, theories. Could this void be evidence of something even more profound? Some physicists have postulated that voids may be the result of the collision of universes in a multiverse. This hypothesis suggests that our universe may not be the only one, but rather one of innumerable universes, each with its own set of physical laws. These universes may occasionally collide or interact, resulting in the formation of unusual structures, such as voids. An alternative hypothesis, though arguably more speculative, posits that voids may represent regions where advanced civilizations have harvested energy on a cosmic scale, effectively dimming the galaxies in that area. Although this hypothesis may initially appear implausible, it is noteworthy that scientists have indeed contemplated the potential for advanced civilizations to exert influence over the cosmic landscape. It is therefore possible that if such a phenomenon is conceivable, it may already have occurred in the context of extraterrestrial civilizations. What then is the significance of this void for Einstein's prediction? In one sense, this observation corroborates his hypothesis that the absolute origin of the universe may remain forever beyond our visual reach. As our observations continue, it becomes increasingly evident that the universe is far more intricate and enigmatic than we had previously conceived. The discovery of this mysterious void by the JWST only serves to deepen the mystery. Rather than finding a neat, orderly picture of the early universe, we are presented with a challenge to our most fundamental assumptions about how the cosmos works. It is possible that this void is just one piece of a much larger puzzle, one that we are only beginning to understand. It may be that it is a sign that our models of cosmology need to be revised, or it may be evidence of something completely new, something we have not yet begun to imagine. The central enigma of this phenomenon can be distilled to a single, fundamental question. What are the fundamental constituents of the universe? For decades, physicists have been engaged in an ongoing effort to provide an answer to this question. It is established that approximately 5% of the universe is constituted by normal matter, which is the fundamental building block of stars, planets, and galaxies. The remainder is comprised of dark matter and dark energy, two enigmatic components that remain poorly understood. It is thus possible that this void is connected to these enigmatic forces. It is possible that dark matter or dark energy may play a role in shaping the universe in ways that have yet to be fully understood. As our knowledge base expands, it becomes increasingly evident that our understanding of the universe remains incomplete. As the James Webb Space Telescope, JWST, continues to explore the farthest reaches of space, it is probable that further discoveries will challenge our comprehension of the cosmos. While the absolute beginning of the universe remains beyond our visual capacity, this does not preclude the potential for the uncovering of new and profound insights into its fundamental nature. Ultimately, Einstein's prediction transcended the constraints of technological advancement, serving as a poignant illustration of the boundaries of human comprehension. The universe is vast, enigmatic, and replete with unexpected phenomena. Despite the considerable advances that have been made, it is evident that there is still much to be discovered. As we continue to expand the boundaries of our knowledge, the mysteries of the cosmos will continue to deepen. However, one thing is clear: we are currently living in an age of exploration, where each new discovery brings us closer to unraveling the greatest mysteries of existence. While we may never fully comprehend the origin of the universe, the journey to understand it is arguably the most exciting adventure of all.